Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother Joel Chaiken. We're here to hopefully show you how to approach SAT math questions. This is from a calculator section. You have this formula. The expression above gives the amount of money in dollars generated by a $1,000 deposit in a bank account that pays R% interest, compounded monthly. Which of the following expressions shows how much additional money is generated at an interest rate of 5% than at an interest rate of 3%? Wow, it's like, to me, it's like so obvious without even, there's only one, even if you don't know anything about this thing, it's this one because it shows the difference of two things. It's like, then you don't even have to understand the interest rate formula.
Yeah, the key is, the question is how much additional additional money is money, or maybe we'll say new money.
Oh, man.
Okay, ready? Added additional is additional is what is how much is added. Right? And so to find out how much is added when you go to 5%, you take what you get at 5% and subtract off the old value, which is at 3%.
Right. That's right.
And again, it's this is the only expression that gives a difference.
Right.
All the other, whatever the other expressions are.
Yeah.
They're not differences.
Well, actually, there's one that may fool you. This one, right? Yeah. There's a difference between the 5 and the 3.
Yeah.
That is not the answer. Okay, but that could confuse people. That's why it's there.
Yeah.
This is really surprising. Why didn't they do the opposite? Why didn't they take the one? Why didn't they put the 1,001 plus 3 over 1,200 to the 12 minus 1,001 plus 5 over the 1,200?
Oh, yeah, that would be more. Yeah,
just a little more. Wow, you have to think a little bit.
Yeah,
but here it's the only choice. I mean,
yeah. Well, sometimes there are two ways of comparing quantities. One, by asking how much additional is the new quantity over the old quantity. And that additionalness is computed by subtracting.
Right.
But there's another way of comparing things. That is, what is the ratio of the new quantity divided by the old quantity? And that ratio comparison is what's given up here.
Yeah, right.
Ratio.
Yeah.
This is a ratio compare.
Right.
And this ratio compare is equal to, 1 plus.
Except we have it there. You don't have to repeat it.
Yeah, no, this is also called a percentage.
Okay, yeah.
This is 1 plus, what would be 100. No, this would be, I'm sorry.
It's fine.
This
would be, ratio.
Yeah.
It's just a ratio. It's how much more it is on a ratio basis. How much bigger it is as a ratio. Yeah.
P percent.
Yeah.
Oh, see, it's P percent, P divided by 100. So if you say how much percentage more, what we do is take this, subtract it from 1, you get a fraction, and then multiply that by 100 to get the percentage
right
more that you get. But they're not asking for the percentage more. They're asking for the additional amount.
Right. That's right. Yeah. Right. So there's only one. So first of all, let's say about the percentage. We do an example. Let's say something is. Let's say you do a ratio, and it's 1.3. Right. Let's say comparing how much bigger is 130 over 100. So you do 130 divided by 100, you get 1.3. 130 over 100 is therefore 1.3, which means that it is, take away the 1 and it's 30% bigger. But that's not this. That's what Seth was talking about.
Yeah.
But notice that you don't even have to know or really even understand where this formula comes from, or you don't even have to use it to actually get a number for anything. So.
Yeah. Well, you just have to notice that, in the left-hand expression here, this is the formula up here called f of r. There's the r.
Right.
F of r, and this is f of 5, and this is f of 3.
Right. Okay. That's it, I guess.
Okay.
If anyone is interested in the after party, we'll say goodbye now. But if you want to hold on just for maybe 4 minutes, we'll talk a little bit about this formula and where it comes from. So let's say goodbye, everyone. Have a great day. If you like us, dislike us, give us comments. Please send us your questions at SATmathquestionoftheday@gmail.com. And if you want to, you've seen this probably in 11th grade math, which some people take in 10th grade. Where this formula comes from, and we could just talk about it for a moment. It actually is very closely related to the problem we did here, yesterday's question, but is essentially exponential growth. And what it is, it's the initial amount plus 1 plus this rate up to the number of periods, number of times the rate hits. Okay, so if it's 5% a year, but it's compounded monthly, every single month you get 0.05 over 12. Every month, this is what you get. 0.05 divided by 2. Seth, let me finish that. Seth, let me finish. Okay. That's the rate. You add that 1, and then you raise it to the number of periods that this rate applies. If it's monthly, it's 12 times the number of years. Okay? So that's how we get it. If you remember from yesterday, we did a similar thing. Number of periods that the rate applies. So that's why for the 12, that's why for 1 year, there's a 12 as the exponent because there are 12 compounding periods. The interest rate is 0.05 divided by 12, which they multiply by 100 to get 5 over point. Wait, this is really bad about the computer. I'm really sorry. 0.05 divided by 12, which is 12 divided by 1200. That's what they get here. That's why this is here. See, 0.05 divided by 12 is 5 over 1200. That's where that comes from. There's the 1 that we're talking about. And the initial amount is the initial amount. And that's where the thing comes from. Now, wait, one more thing. Most of the time, teachers require you to memorize it. Sometimes teachers in a test would give it to you. You may have to memorize it. It's always a good idea when you memorize something to try to understand where it comes from, because it helps you memorize it, and it also helps you basically do the problem. So if you're asked to memorize this or know it or use it, try to understand where it comes from in general. Okay.
Just one. I prefer to avoid problems with symbols. The R here is not the same as the R here. Okay. I would rather use instead of that R in here, I would write, say, R1.
Yeah.
So R1 equals the monthly rate.
Right. Yeah, absolutely.
Okay. And then furthermore, R here, monthly rate, is the fraction, which is the monthly percentage,
right,
divided by 100.
Yeah.
That is R1. And here little r is the percentage, the little r is the yearly percentage. They divided it by 100 to get the yearly fraction, and then they divided it by 12 to convert the yearly fraction into the monthly fraction. Right. And so I guess also I would say that R1 from this formula is R divided by 12 divided by 12 times 100, is where the 1200 came from.
So, yes, that's all right. I was schleppy about that. But it also emphasizes the importance, really, of not even worrying about the symbols, but understanding what the formula says. And then you can make up your own symbols. You could say P, you could say L plus 1 plus Z divided by M. Right? It doesn't matter really what you write, but you have to understand what the formula does and what the meaning of everything in that formula is. That's the highest level of understanding. Then you can be as schleppy as you want with the symbols, because in your head you know exactly what everything means.
Well, I think it's a bad habit to be schleppy with symbols.
I agree.
Yeah, so just repeat not being schleppy.
Okay.
Yeah.
Well,
teachers do very well with teaching this stuff when they insist that when you use symbols, you write a statement about what every symbol is for,
right?
What it means.
That's
when you do a problem on paper, or type it in to hand into schoolwork.
Absolutely right. And you notice when I went through this thing, if you go back to the video, when I said everything, I actually said what everything was. I may have been inconsistent, and I may have changed what R was. But every single time I said something, I said what the symbol was.
Yeah.
So absolutely right. Absolutely right. Yeah. When you do problems, you should write out what every symbol means.
Yeah.
Yeah.
Now, SAT questions will often have written in the question the meaning of the symbols that are used.
Yeah.
This question has that example.
Sure.
It says the bank account pays an annual interest rate of R%.
Yep.
So that defines what R means in this problem. I'll underline that. I'll underline the critical line. This tells, this statement here tells what R means.
That's right. So the SAT question did good modeling, and they always do.
Yeah.
They really always do. You'll go back to all the questions. If they use a variable, they tell you exactly what it means with total clarity. So I guess that's it, right?
That's it.
That's it. We're done. Okay, everyone. Have a great day, and we'll take care. Have a good day. Bye-bye.